guys, welcome back. This is Daniel Pinheiro from danielpm1982.com. Okay, so now let's go to our next subject, which is how you can debug using IntelliJ. And the debugging process is pretty much simpler than the testing process, because you don't have to write any class or import any specific dependency as a unit or use any specific syntax. You only have to mark the breakpoints at the parts of the code you want to analyze, and then instead of run using here the right arrow button, you press here the debug button, either for the normal classes, as for example we could debug the domain classes or the helper classes here as the DAO or the populate helper class, or even the main class here, or even we could debug our test classes after we write them to search for the origin of any unexpected exception or error along the testing validation process. So firstly, let me show you, for example here, how to debug this main class that after we create our MVC architecture, it will be kind of our controller class. So for debugging, you gotta know the design of your class. For example here, we have these two fields. You don't debug the fields, you will debug the methods. It would not make sense to mark any of the fields to debug. We would mark any of these methods, either the main one, which calls all the others, or the populate sample data method, or the print data, or the print data per client, or even we would mark all of them. But let me just mark here one, which is the top one here of this class, and through this one we'll analyze all the others. We can analyze here the populate sample data, we can analyze the print data, or we can analyze also the print data per client. So as you see, you just mark here with a breakpoint either the method. For marking, you press here on this space, and for unmark or for delete the breakpoint, you just click again. So if you click here, this point of code will be marked so that when we run the debug, it will stop here at these breaking points, and then we will be able to run line by line or enter deeper inside the method stack. For example here, we could enter inside the populate sample data, and then it would go here to the populate sample data method execution, and we could then analyze line by line inside that one. We could even enter here deeper at the populate sample data of the populate helper class, and so on. So we can mark the methods, or we can mark any method call inside any of the methods. For example, I could mark here, and as you see, the format of the breakpoint differs. If you mark a method, it will show this type, and if you mark any inner method call, it will show you this other type of breaking point. But basically they have the same function, which is to simply stop the debug running flux so that you can analyze line by line and enter deeper inside the stack call of any of this line, and later go back to the outer methods to proceed with that flux until the flux ends. So let's suppose we had an error or exception that we wanted to debug, and that supposedly would be coming from this populate sample data call. So we would have to put the breakpoint here at this method call, or we would put the breakpoint at the main method here. Let me put at the main method, and then we can go through each one of the lines, and when we arrive at this line here, we just enter deep to investigate where that exceptional error would be coming from inside this populate sample data method execution stack. So after you mark here with the breakpoint the point of the code, either a method or a method call you want to start debugging from, you simply press the debug button here. We select the class here, and then we can either run that class or we can debug that class. So in our case we would debug, or more easily we could simply press here any of these two right pointing arrows, for example this one. Instead of run the main, we would debug. So let's use this shortcut here, and as you see it has run the class into the debug mode, and it has stopped right where we marked with that breakpoint, which is at the main method here, and it has gone to the first line of it so that we can analyze the state of the code or of the fields or local variables of that method at each of the lines inside that method we marked with that breakpoint. So inside the main, the first row is this one, and here for this first line of the main method you can see that the fields we have are basically the constant hello static field with a hello world string expression value for this static constant hello, and it both shows you here at the variable side of the debug window, and also it shows you here on the right side of the line. For example, it shows that the hello constant here has at this time of the application run the hello world value associated to it, and it has been associated since here at the start. So you can see that it not only shows the state for the variables at the line that it's on, but it shows at the previous lines. So you can see that at this first line you have the value for the hello variable or constant field. Here you have at this time the order item list state or value, which is null. We have not yet populated the database or received the order item list resulting list. So the order item list here is as we expected with the null value. The string args array here of the main method is also empty. There are no args being passed to the main method when it's called by the IDE when running this application. So it also shows the same here below at the debug window on the variable side. So the hello static field with a hello world value, and the order item list still with a null value associated to it. And here on the left of the debug window it basically shows the line and the method as well as the class and the package. And one of the actions that we can use is the step over action, or you can use the F8 shortcut. And what this step over does is basically ignore this line and go to the next line at the same layer of our code. So it will simply ignore this one and go next to the other one. So let's test it. Step over. Okay, you can step over all the lines until you find the line you want. In our case, this third line here inside the main method. So let's step over once more, and now we arrive at the point that we wanted to debug, which is the populate sample data method call. So here, before this method is called, you can see that The order item list is still null, as expected. It has not yet called this populate simple data. Also here you see that the order item list is null. If we select here step over once more, it will go to the next line and it will execute this method call. And you will see that the state of the order item list static field will change from null to the returning list from the populate method at the helper class. So let's just step over once again to see that now the state of the order item list has changed to an array list of size 7. And you can actually see here the content of that list, which are these 7 items or other items, even with their values according to the data we set at the populate helper class and at the populate simple data here. So it will show the returning list for this data just when the populate simple data method of the populate helper class is called from the main class through this local populate simple data method here. As you can see, when this method populate simple data is called from the main method, then it calls this still local populate simple data method, and that will call this same name method at the populate helper class and get back a list with all other items populated by this method and associate to the other item list, which is this static field here, altering the value from null to another item list of size 7, which you can also see here at the debug window and at the variable section of this window, and even with the values of each of the items of that list. So here are all the values for our returning list that's now associated to this other item list static field. And another thing that we could do is not simply run this method call, but to enter deep inside it using this other action here, step into, and for exiting for a higher level of the call stack, we would use this other one, step out. So for testing it, we have to rerun. So let me show here. For stopping the debugging, you simply can stop here. So the debug has stopped. We will rerun the same class that we had previously set to debug by simply click here at the first action button on the left, rerun main, because we want to get to this line here at the populate simple data call and not simply run it, but step into it and see the specific method calls inside its calling stack. So for it, we'll step over 2 times. Now we arrived at this line, and then we'll not step over again, because first, before running it, we want to check inside it. So for stepping into any method call line, you use this other action here, step into or F7, and then it will step into this method call and go to this method here. So if we click here, step into, it will go here to the first line of the populate simple data local method at the main class still. And then if we step over, it will simply run it and get back to the normal flux here at the main method. Or we can also step into here so that it goes to the populate helper class and to the first line of this populate simple data method there. So let's step into, and it will go to the populate helper class now. Okay, here it is, and it has stopped at the first line of the populate sample data method here at the populate helper class, not at the main class anymore. So here we can simply step over each of the lines, or if we step into, for example, it will step into this create and add client method call, and it then will go here to this method create and add client, which is called here. Let's step into again. So here is at the create and add client method at the populate helper class, and at the first line of this create and add client method. And here we can simply step over, or to go back to the level where this method was called, we could simply step out, so it will rise on the level of the stack, and go back to the populate sample data here at the line where that method was called, which is this first line. So let's step out this method and go back to where we were, which is this line 1 here at the populate sample data. And we could do that for every one of the lines here where any method is being called. And in every line here we call a create and add method. We could get into any one of them, but let's just step over all of them until, for example, you arrive here at the list. In here, the state at this time, you can see the state of the application will be all these local variables here of the populate sample data method with a value associated to it already. We have not run this line here yet because we are over it. When we are over a line, we don't run that line until we step over one more time. So until now we have not yet run this line here to return the list, but we have the states of all these variables already set to the instance created and persisted at the database. So we can check that by looking here at the variable side of the debug window. So we have the client 1, 2, 3 and 4 with the respective values. We have the product 1, 2 and 3. We have the other client 1, 2, 3 and 4. And we have here the other items, the 7 other items created that will be returned as another item list to the method at the main class that called here this populate sample data. So if we step over one more time, it will get back to the main class, to the line where this populate sample data was called. So let's step over once more, and it returns to the main class, and at the main class to the method, and specifically to the line where that populate helper class populate sample data method was called. And here, if you pay attention, it has actually not yet run this line. It has step into and now step out the populate sample data at the populate helper class, but now it has returned to the main method but not yet run this line here. When a line is selected at the debug process, it has not yet been run. So for running this and calling this method and associate the receiving list to the order item list, which is still with a no value here, you gotta step over once more, and now you can see that this previous line has been executed and that the static field or the item list is now associated to the returning order item list from the populate sample data method of the populate helper class. Now if you step over again, it will go back to the main method here, where this populate sample data of the main class was called. So let's step over again, and it goes back here, and so on. You can step over to whatever method call you want, and arriving at that method call line, you can step into, for example, at the print data, you can step into, go to the print data method here, analyze it, step out and get back, step over again, and if you step over one more time, it will finish actually one more time, and it finishes the debugging, because now the application has finished executing all the methods and there's nothing more to run or to debug. And to see the breakpoints, for example, I could have put many other breakpoints here. You can use this action here, view breakpoints, at the left side panel of the debug window. If you press here view breakpoints, you can see all the breakpoints, both the exception breakpoints you can use, and IntelliJ already gives you some options here, or the normal breakpoints that we've set at our code, either at the methods or at any method call throughout the code. So if you want, you can unselect or unmark here some of the breakpoints. It will not delete the breakpoints, it will simply enable it. So you can leave only one breakpoint and then call the debug again, and it will not see the others, it will see only the ones marked here. Or you can delete them, for example, by selecting all of them and pressing here the remove option. So all the breakpoints we had set are now deleted and not just enabled. Okay, so that's basically it for the debugging process. And let me show you that you can do the same process at the test classes. The debug process is actually the same. So we simply have to mark any breakpoint at our testing code. For example, let me show you here at the failed test nested class. Let me unmark these two lines here to produce a failing test. And now we'll put a breakpoint here at the populate data failed test, so that we can step over each one of these lines until you arrive here. And here I'll show you the alterations that we did on purpose to make the test fail. So I've put the breakpoint here, and now I will call the debug, not the run, the debug action over this test class. And you can also see at this debugging window all the executing stack and the states of the variables at our testing class. But I'll just step over here till we arrive at this line. For example, here, after we execute these two lines, we will have an expected and an actual lists, and those lists will be the same. If you see here, this order item list expected is of size 7, and this other one is of the same size, and they will also have the same content on the same order. So they are, for now, at this time, before this line runs. This line here below is the line where we induce the error. So before this line runs, these two lists are the same, and you can check that here at the variables state of the debug window. So if you open here the order item list expected and the order item list actual, you see that they are exactly equal, and you can even check the content to see that they are also the same. Both the number of items as the sequence of those items, as well as all the data on each one of the items. So until now the test is passing, but as soon as we step over once more, this order item list actual variable will be pointed to a new list that will be instantiated with the same content of the previous order item list here above. But when we step over again on the next line, it will remove the first item from that list, so that the list now is different from the expected one. And we can check that here at the variables state section. Actually, let's step over once more so that we can run this line here and delete this first item from the list. Okay, now if we go here, we can check that we have a 7 item expected list, but at the actual list we now have only 6 elements because the first element has been removed, and then the list has been rearranged so that the first element here on the list is now the second element from the list before. So then JUnit will compare those two lists when we run this assert iterable equals, and it will find out that now these two lists, the expected list from the database directly and the actual list, which is the list received at the main class, are now different because one of the items of the actual list has been deleted, and so the test will simply fail. So the test will fail because of this line. And if we go here to the run method and run that test method, we will see that it fails, and it actually tells us why, as I've already showed you, showing the error message that we have set and showing you that the problem is at the first element of the actual list. So when we debug, we actually do not run the test, we simply debug, and then we gotta go to the run and run the method here to see that the method has actually failed. So one thing is the debug and the other thing is the class test running. And if we want to delete these breakpoints, we simply click again, and this is how you debug a testing class. Okay, so now we've reached the last subject of this first version of our Java application project using IntelliJ, and the last subject will be how you can integrate and use Git and GitHub from inside IntelliJ IDE. So the first way you have is using the file new project from version control, and then it asks the URL of the repository you want to clone from, or you can log in via GitHub here to select the repository available at your account. Another way would be to use here the VCS get from version control. It would go to the same window here. Another one, let me close here this project, is the initial screen of IntelliJ, where you can get here from version control. You can choose the option here to get a project, an existing project from your version control, and it can be an empty project or a project, a full project with all the structure already created. For example, you can create a new empty folder using GitHub site, and after you create that, you can go here and get or clone that initial repository to a new project at IntelliJ and then start creating all the project classes and all the structure of that project. Or you can clone any other already developed project that any person has turned available through GitHub. In both cases, choosing this option here, get from version control, and then it goes to the same window of those two other options we showed you before. But before I configure my GitHub account into IntelliJ for integrating it with my account at GitHub, and in your case with your account at GitHub, I will close IntelliJ and I'll do it manually using Git and using the GitHub site for you to know that it's possible to do that manually, and then compare to the option of doing that automatically by using IntelliJ integration in all the user interface that IntelliJ offers for you to do the same thing. So for that, you gotta have Git installed at your machine. You can go to my site danielpm1982.com and look for a video where I teach how to install Git on Linux and test it along with GitHub. And after you have Git installed, then you can start what we're gonna do now, which is basically go to GitHub site, create an empty repository, and then go to the local Git environment and clone that GitHub repository locally. So first sign in to your GitHub account. If you don't have a GitHub account, create one. I already have, so I'll just sign in to my account. Okay, this is my GitHub account. Here you have my profile. Here you have all my public repositories. Okay, so now we'll create a new repository that I'm gonna call test. Here at the repository name, you should always use lowercase letters, as it will be the URL path for your repository. So you should not use uppercase letters. You can put a description here. You can choose as public or private. I'll set it as public. You can initialize the readme file. You can add already the .gitignore file. I generally add it later at IntelliJ. Then you select this option here, create repository, and that's basically it. So now we have a repository at my account and at this path /test. And for you to get the URL of this repository, you click here at this option to download code, and here you have the complete URL path that you can copy and then clone that through your local Git. So I've copied the URL. So now just minimize here and open your terminal. Go to the place or folder where you wanna create your project. I'll go to IntelliJ Workspace folder, and there just use the git command git clone and the URL that you've copied from the GitHub repository, which is this one. So with this, Git will clone locally that initial repository we created at GitHub, and here you have the test repository, which is the same repository that we have at GitHub. So if you go to this repository folder, you can see that we simply have the readme.md file, and if you use at the ls command here the -a for viewing all the files including hidden folders, you will see this .git folder here, which is the one and main folder for Git to make all the version control of that project. So for the test folder, Git will use this .git files to control the whole test folder, either in IntelliJ or at the terminal. So let's see the Git folder content. In here you have all Git folders and files, the branches, the config, description, the head, the hooks, the index, the info, the logs, the objects, the package refs, and the refs. So I'll not enter in details about how Git works internally. I just wanted to show that everything that Git needs to manage the version control of this project or any project we had initialized through Git init, it will have this .git to manage that. If you delete this .git, you won't be able to manage that folder anymore unless you create again that folder through git init or front cloning the whole repository again, as we did with this test repository. So if you wanted to work with this project here on the terminal, you could by creating files and put some data inside those files, or creating any other number of folders and then adding from the working area to the staging area and then committing that to the local Git repository, all of it inside this .git folder. And later you could even push that to the remote repository at GitHub. You could do all that without using IntelliJ. But as we are developing with IntelliJ, one of the ways we have to now use this test project with IntelliJ is to ask IntelliJ to create a project inside this folder test, into which we have already created the .git folder. So when IntelliJ creates a project here inside, it won't delete the content here. It will leverage from this .git folder to get all Git information and synchronize the project at the Git IDE with all the information here inside the .git folder. And then Git will be automatically habilitated at that folder at IntelliJ. So here we have cloned this test from GitHub, and of course it already creates the .git and also the readme.md. And now we simply have to create a new project at IntelliJ pointing out to this same folder. So you can leave here and then open IntelliJ, and I'm gonna create a new project. I will simply create a Java 1, but you could create any other type of project. Select the JDK you want, then select next, create project from template. Here you set the project name, which will be test, and the project location here you must, in this case, set to the same folder where we have the .git folder created by Git when we cloned our remote repository from GitHub, or where Git has created a new version controlled project by using git init. So regardless of how you created that, the fact here is that you gotta point your new project at IntelliJ to the same folder where that .git folder is, and then it will be automatically synchronized with Git and with all the Git information stored inside that .git folder. So you simply pointing out to the test folder where our .git folder is and click finish. So now regarding the synchronization of IntelliJ with the Git information inside the .git folder of this test folder here, the .git won't show here at the project folders because it's a hidden folder. But if you go to your directory manager and to the workspace and to inside that project folder, which is the test here inside the workspace, you see that now we not only have the .git hidden folder in the readme.md, but we have the other folders of IntelliJ that have been created into the same folder where our .git folder is. So because we have the .git folder here created by Git, automatically this project created by IntelliJ is now integrated with Git without we having to do anything else. For example, now you can see here a tab for Git that we hadn't before, because now this project test is already integrated with Git, and you have a local master branch, which is where the version of all these files and folders is. It's the only branch we have locally, as well as we have the origin path, which is automatically created by Git when you clone a repository from GitHub, and also the master branch here of our remote repository. We have a local repository with a local master branch, and we have a remote repository also with a single branch called master. And those two repositories, the local one and the remote one, are already synchronized, and as such you can do all the add-ins you want of the files and folders from your working area to the staging area, then commit those to the local repository at the master branch here, and then push that to the origin master branch at GitHub. So, and also you have this commit tab here on the left margin of the main window, which you can select to see individually all the files. We can close this one here, and at this tab one here, not on Git but on commit tab, you can see all the versioned files. For now we have no versioned files yet, but you can see here all the unversioned files, and you can select whatever files you want to start versioning, or you want IntelliJ to set Git to start managing, either by selecting here. For example, you can select the .git ignore file that we may change later, the main.java class. Here you have the folder. You can set that individually, or better, if you close here and open the project structure, you can select here at your project structure the folders you want to start versioning. For example, the .idea we should not version because it's an internal folder for IntelliJ. It's not part of our code. The out folder here, as I've already mentioned, has all the compiled files. We actually don't have to send that either. But the source folder here, we want to start versioning, specifically the con.daniel1982 folder. So for that you click the right button, Git option, and then add. So now you see that the color of the file has changed from red to green, and if the file is green, it means that Git is now versioning that file, or that Git is seeing that file, and any alteration you do on that file, it will be visible or managed by Git. So now that this file is now versioned, you can go here to the commit tab, and you'll see now this other section here, default change list, with the versioned files. You have the unversioned ones. These ones won't be committed either locally or remotely. But now we have one file, versioned, which is the main file of color green, that we can add and commit locally to the Git repository, and then push that to our remote test repository at GitHub. So you can mark that file. Remember that at the remote we don't have this file yet, so it's a change. That's why it's at the change list, because when compared to the original and to the actual version at GitHub, at the remote repository, there's no main file there, so it detects automatically that this main file is a change compared to the remote state of the repository. So we can commit and push these files we have here, versioned, to the local and remote repository. And for that we just select here what we want to commit and then push, and here below we write the message for the commit. For example, add main class, or whatever message you want to put on the commit. And here below you have, still inside this commit tab, we have some options. We can commit that locally and it won't push automatically, or we can choose commit and push. So as I want to demonstrate that, I'll select the commit and push. So for that you have to add on IntelliJ these global properties, and we have to do that only once. So let me add it already and leave this option here, set properties globally set, so that we won't have to do that again for any other project, and select set and commit. So here it's showing what is going to be pushed. Here it shows the structure of that. Here it shows the hash code, or the initial part of the hash code. Here the global property that I just set, my name and my email. Here the date and time, and then we select here to push. So the global properties that we've just set, they were simply to identify the commit. We have not yet logged in my account. So now if I'm gonna to add or alter anything at my account, I have to log in, and that's what I'm gonna do now. You can do that using a token or logging in via GitHub. Here you authorize IntelliJ to access your GitHub account, and then you put your username and password. And also, as with the global properties, you only have to authorize this synchronization with GitHub from IntelliJ only once, and it will keep you logged for whatever other project you create. So you just have to log in once. Okay, now my JetBrains IntelliJ is integrated with my GitHub account. Authorize JetBrains. Okay, you have been successfully authorized in GitHub, and then you close the browser, and now IntelliJ already has pushed our main file to my GitHub account, remote repository. In here, when it asks about if you want to always add a new file to Git, you don't have to add that. So I'll just set here don't ask again, because I like to add it manually. For example, I never add the .idea folder files, so they will keep unversioned. The out folder also we don't have to add. And what we have to add is the source folder files. You can do that if you had a bigger structure here. Inside this source folder, you could have pushed the right button on the folder itself and not on the files, and add that to Git. So it would add all the files and folders inside the source folder here. And also the test.iml, which is the module file for this project. I also don't have to add to GitHub or to my local Git repository, and neither any dependence we use. So for this very small project, we would simply add this source folder. But if you had any other folder, for example images folder, or if we had a Spring application here with many folders, we should mark or add all of them to our staging area or to be versioned by Git. And then when there appears any change on them, we could see that they would be added here to the change list. For example, now there's no change at all at the versioned files, which is basically the main file. So that's why it's not appearing here. But any change I do at the main file, let me just change anything here. I'll just delete this line and delete these spaces. Actually, this space I always leave, but no other space down here below. Then this main file now, which is a versioned file, would appear again at this commit tab as a versioned and changed file that we could select to commit and push again. So let me go to my GitHub account just to show you here what we have pushed already. So IntelliJ has pushed this structure source /con/DanielP1982, and inside we have the first push of the main file, the first version of that. If you click on it, you have here the initial version, still with the space and with this write your code line here that now I have deleted. And if I push again, commit and push again, this new version without the space, without that commented line, here on this window that appears after we choose to commit and push, the files are already committed locally to our local Git repository, but not yet pushed to GitHub. If you go here to GitHub, you will see that this file is still at this initial version. So IntelliJ has not yet pushed it here. It has committed locally, but not yet pushed. For pushing, you have to select here push after committing. Okay, and now it confirms here one file committed, add main class, and now pushed one commit to origin/master. And if you go there at GitHub again and update the page, you see now the latest version of our main file, without that commented line and without the space here between the declaration of the main and the declaration of the main method. So the main file also disappears here from the change list, because now it is still a versioned file, but it has no difference with the remote version of the same file at GitHub. So we can do that with all the files we have and that we have set to be versioned at our project. And if you go here to the Git tab down below, you can see also the commit timeline. For example, here we had the initial commit. If you click on it, we had at that state only the readme.md file. We had not yet created this test at IntelliJ. So you have the structure at that time, and you have here the initial commit info, the hash, the name of the user, the email, the date and time of that commit, and the information that it has been committed by GitHub and not yet from this machine. That was the first commit that GitHub has done at GitHub site when we created the remote repository. Then we have the second commit that I have done with this first version of the main class, and then we have the last commit with the second version of the main class. And now you can see that the origin or the remote head master and origin/master are all synchronized with our local repository and master branch. If we, for example, change it again, this main file, and simply committed that locally, for example, let me, instead of choosing here commit and push, I will just commit, I will not push. So it will commit only to the local Git repository. So that now you can see here at the Git tab window that our local and remote repositories for this project are not synchronized anymore. So we have committed but not yet pushed. So locally we are one commit ahead if compared to the remote repository, and you can check it here that the remote origin master branch still have only 3 commits, the 3 initial commits, but the local master branch now is with 4 commits, and that this last commit is only at our master branch but not at our origin master branch. Our origin master branch is here, still on the 3rd commit state. And why is that? Because we have not yet pushed this local master branch commits to our origin or remote master branch. So the master branch, see here, has not yet received the 4th commit, but locally we already have the 4th commit here with this alteration that I did here, which was simply to add this empty line. So the main class locally now is in a different state of the same main class at the remote repository. So for seeing the difference between the 2 files, the 2 versions of this main file, between the local version and the remote version, you can go here to the file itself, click the right button, go to the Git submenu here, and choose to compare with branch, and then select the origin or remote master branch, and it will compare this local structure or file, specifically main file, with the same file at the origin master branch. So here is the diff, or the difference between the local master branch file of that main class with this empty line here, and the origin or remote master branch same main file with a difference exactly at where it shows here, this green line. For example, it shows the difference here on the right, and it points out also to the place where that difference is on the origin master file, which is here between the public static void main and the systemout print line. So for both versions to be equal, we would have to push this version to the remote master branch, and then we would have this empty line also between these other two lines here at our remote main class file. So this is the diff command of Git, but using IntelliJ integrated user interface. And the same thing you can do here instead of clicking the right button and go to the Git compare with option, you can go here to the Git tab here below. You go to the branch which is ahead of the other one. In our case here is the local branch. We have 4 commits here, and at the origin or remote we have only 3. So go to the one with the most commits, because we want to show this difference of this last commit here. Go to that, and here you have a shortcut for showing the diff, which is exactly the same command if we were on the terminal and used git diff for this file. So you just click here on the last commit and press here show diff, and it will show more easily or more rapidly the same diff window that we had when we used the menus. And another thing we have here down below on the right is this master tab here, which is the Git branches. So here on the same tab you can create a new branch locally. You can check out any tag or revision you have. You can check out the local master branch where we are already. So if you click here, it won't change anything because we are already at that local branch master. And this structure here at the project structure refers to that branch we are into. And also we can check out the origin/master branch, and you see that this structure here, or at least this file here, will change because it won't show this last version. It will show the last commit version that in the case of the remote repository is one commit behind. So for the remote repository, this last commit doesn't exist. And if you check out here to the master branch of the remote repository, you see that this version of the main file will disappear, and it will appear the last version committed to the remote branch. So when you press here at this origin/master branch, there's the option here to check out, to compare with the current branch, to show the diff with the local working tree, to rebase, to merge that branch with the actual branch, but I'll simply check out. And for checking out, our local working space structure will change to the same structure at that remote branch. So you have an option here to check out and rebase, or to overwrite. I'll overwrite the actual working space content with that of the remote repository. So now if you open the main file again, it will show you now the version of the remote master branch, and it has overridden the version of the local working space, and actually it has overridden the last commit, the fourth commit we had here at our local master branch, with the last commit at the origin master branch. And actually it has done with that overriding a hard reset. But we could also have done a rebase for keeping our last commit at our local master branch. So if you wanted to check out locally here at our local master branch to a previous commit, we could simply click the right button, check out to that commit, and now we have here at the working area the same state we had when that first commit was created. If you, for example, check out this other one, we have now the state at the working area of that commit time with the main class here, the original and initial main class, still with the space here and with this commented line. So if you wanna now check out to the last commit we have here at the local master branch, we can simply click the right button here at the last commit, check out, and for checking out we can check to the commit itself, this is the last commit, or to the master, which always points out to the last commit. And that's how you can change or check out to different commits inside your local or remote branches. Let me now create another branch here locally. For example, select here local, new branch. Let me name it feature/1.0. Now we have another branch here. We have the master branch, which is the release branch, and now we have a feature1 branch with the same state of the master. For now they are at the same state, and it has automatically checked out the feature1 branch. So now we are not on the master branch anymore, we are at the feature branch. We can alter the file here as we want. We can then go here to the commit tab and commit that change, and it will commit to this local branch here, feature1 commit. So it has committed one file, which is this file with this content here. So close the commit tab. So at the feature branch now we have a last and different commit. So this feature branch now is one commit ahead, both the remote as the local master branches. And if I want to go back to the master branch, I can simply check out here. It go to the state of the last commit at the master. And if I check out now the feature1 branch, it goes to the commit of that branch, including the last commit here, which is one ahead the commits from the master. And if I want to push that feature branch to our remote repository, not merge it yet to the remote master branch, but simply push it to the remote repository, I simply set here push by clicking the right button over it and click push. It's already synchronized with Github. Okay, it shows a message showing that it has pushed that feature branch to the origin repository, and it has created that new branch there as well with these 4 commits added. So here you have now the feature branch both at the local repository as at the remote origin repository. And if we go now to GitHub, we have now two branches at our test repository. We have the master that we had already, and now we have the feature one branch, which we can simply select to check out to. And if we open the main class at this new feature branch, we will see this last state of our local working area pushed to that remote feature new branch. Let me just go back to the master branch. So now I'm already at the master branch, and now I can delete or merge that feature one branch with the master. You can go here to view all branches and delete here any branch you're not checked out to. So I am at the master and I can delete my feature one branch. And if now I go to the code section, I'll see that I have now only one branch, not locally but at my remote repository. So if I go back here to IntelliJ, I'll check out here locally to the feature one branch that I have deleted from the remote repository. And if I do a fetch on all remotes, it will update that we have deleted this feature one branch remotely. So let's do a fetch. Okay, now it has the actual structure. At the remotes now we have only the master branch, and here locally we have the master branch and still the feature branch with this actual main file state. So through here you can check out the branches, you can create a new branch both locally or remotely. You can also go here to the Git branches and also do that, create a new branch, check out whatever branch you want, either locally or remotely. You can merge branches. For example, let me check out the master one here, and we can merge the feature one branch into the current one, which is the local master branch, and we can delete the feature one branch. So we've just merged the feature one branch, and as we won't need it anymore because we have already merged all the commits from the feature one to the master, we can now delete the feature one and so on. Here at the VCS menu, you also have basically all the actions you have from here at the commit tab, and from here down below at the git tab. This commit tab here is basically the list of versioned changed files that you can commit, and also the list of unversioned ones in case you wanna start versioning any of them. And the git tab here is basically regarding the local and remote branches in case you want to check out the commits of any of them, as well as to check out or to create new branches and merge them, or make any pull request to a remote repository you don't have access to. So at here at the VCS menu, you have all the options to do all we have at those git tabs. So you can commit, you can update, and the update here means the git pull command, which are actually two commands, fetch and later the merge. And you can do that either merging the incoming changes into the current branch, or you can rebase the current branch on the top of the incoming changes so that you can have a more linear commit line. You can refresh file status, you can create and apply patches, you can clone or import a project from the version control system or the GitHub into your local workspace. You can, here at the import into version control, you can even create a Git repository. Here at the Git submenu, you can see the branches, can also merge stash and stash changes, which is simply locally saving them for later committing if you want or not. You can reset the head pointer. You can see the remote URLs. In this case we have only the origin as remote for fetching and pushing, and this is the URL that we set when we cloned the project from GitHub. You can change that also. If we want to change the remotes, you can clone here another project, you can fetch this actual project, you can pull, which is the same as update here. In the pull again we'll make an initial fetch, then a merge with or without rebasing. You can push also, so instead of using here the commit tab for pushing the unchanged version, you can instead go here to VCS, jet, and push. Obviously after committing those changes. You can rebase, you can create pull requests at GitHub directly from here, and you can also view pull requests as well. So IntelliJ is completely integrated with all the actions or commands from Git as well as GitHub, both to create remote repositories as to rebase or create and view pull requests from GitHub directly here at IntelliJ. So that's basically it, the integration between IntelliJ and GitHub. So let me close this product and I'll actually erase it. If you want to delete a project from your workspace, it's very simple. Here it's basically a recent list of the projects you've opened. If you delete here, for example the test recent opened project, it won't delete the project. For deleting the project, you just gotta go to the workspace where that project is and delete it. And for deleting the test project directly on GitHub, you only have to go to the project test and go here to setting and go here below to delete this repository and confirm here with this message. It asks you to type this path for confirmation and you select here to delete, and then if you go here to repositories, there won't be that test repository anymore. So we've deleted the test repository both locally as at GitHub. But what I want to show you now is how you can create a project at IntelliJ and only then integrate that project with Git and also push that to GitHub. And for that I'm using this project we have, this IntelliJ-demo project, and this will be the first version of our project. So if you already have a project with all the structure created and you want to send that to GitHub, one of the options would be you would go to your terminal, you would use inside that project folder the git init, then you would configure the remotes, and lastly you would have to push the master branch to that remote URL. But before all that, you would have to create the respective remote repository at GitHub for getting the URL and setting that URL to the remotes for fetching and pushing at your local Git project folder. But instead of using the terminal, now let's use only IntelliJ. And as you can see, if I go to this project at the workspace, there is no .git folder here. That's why this project we have is not synchronized with Git, even locally, much less remotely. So how to synchronize this already created project with Git locally and then synchronize it and push it to GitHub. For that, it's very simple. You can, for example, select here VCS, import into version control. If you select this option here, create Git repository, it will create one repository locally, but what we want is to share this project on GitHub, and this option will create the repository at GitHub. We first gotta create it there, then we create it locally and synchronize it with the remote one. So first let's create the remote repository at GitHub at this option, VCS, import into version control, and share project on GitHub. So I have already included all my data at IntelliJ, both my global properties as my username and password for my GitHub account, and I have already authorized GitHub to let IntelliJ use my account for pushing and for pulling any data. So when we select here share project on GitHub, it will go directly to the name of the repository we want to create, which will be the same name of this project, IntelliJ-demo. You can select here if you want it to be private, but I'll leave it public for you to be able to clone it or check it out at my GitHub profile or account. Here the remote will let the name origin as default. Our URI for that project will be associated with this remote origin name. This will be our remote server, and the description will be a simple created Java project using JetBrains IntelliJ. And as you know, this is only the first version. We'll then upgrade the versions during all the next lectures. And then you click share, and then it asks for which files you want to keep versioned. I'll check the images folder files. I'll check the source ones, all of them. I'll check the test ones. For now we have only the main test class here. I'll check the main class, of course. I'll uncheck this module file here. It has nothing to do with our code. It's used by IntelliJ only. And I'll check the .git ignore file, but actually I'll change that later for a custom git ignore file, but I'll let it already versioned. So, and this is the initial commit. We can simply leave this commit message, which is the same message that GitHub uses when you create the repository there directly. So I'll leave this message and I'll click add. So IntelliJ will add all these checked files to the version control system, and any change we do on any of these files, that file will go to the changed file list here at the commit tab, and then we can commit and push all of them or any one specifically. So let me first add here to create the remote repository and successfully shared project on GitHub. So now this project here, all the project except the ignored files and the red files here that we are not versioning, all other files are already at GitHub. So let's go to GitHub and check at my repositories that now we have managed to create this IntelliJ demo repository directly from IntelliJ. And if you open it, you see all the files that we checked to be versioned already pushed to that remote repository. So here is our main class and all other classes we have at our workspace. So let's go back to IntelliJ. So now the commit tab here is available for you to see the unversioned files that we are not sending to GitHub when we commit, and the default change list, which will show us any changed file from those we have checked for IntelliJ and Git to manage. And we also have down here below the Git tab with the console, the Git console here, that shows you all the with the console here and with the log section here, with the local master, which is this one, this structure, with the local master and the remote origin remote master. And as you can see, both are exactly at the same state here. There's no difference between them, because there's no difference on the files either at the master branch local or at the master branch remote. Okay, so that's it for Git. And starting from the next lecture, we will start evolving this first version application, and now actually create many branches for all the versions that we're gonna create, so that when you go to my GitHub profile to see this repository, you can check out each one of those branches with the specific version of this project. This state here, which is actually the current one for now, will be the first version. It will be on a first branch, but I'll create other branches for the other states of this project when we start, for example, implementing the database, creating the DAO classes, using JDBC, and all this we're gonna do on the next version of this project. And later also other branches for the MVC Spring version and Spring Boot version with Spring Data, and lastly with Spring REST version. So at my repository for this project, IntelliJ-demo, you will have a master branch with the current version until then, and you will have many branches, each branch having a specific version of this project, being the first version, this one here. And you can check out to whatever branch or other version you want to see all the evolution of this project throughout the next lectures. So thanks one more time for your attention, and see you on the next lectures.